Hello students of grade 11 applied maths. We'll do question number 12, 13 and 14 in the video. Show that the relation R in the set A given by R that A minus B is divisible by 2 is an equivalence relation. Okay. A is given 1, 2, 3, 4, 5. So modulus means whatever you do, the value will be positive. If you do 1 minus 2, we get minus 1. Modulus means positive. See, 1 minus 5 is minus 4, for example. This is positive. Okay, we take only positive. We're going to show that it's an equivalence relation. That means we have to prove that it is reflexive, it is symmetric, and if it is transitive also. Now, since the set is already given 1, 2, 3, 4, 5, so what we have to do is we'll try to get the relation. So from this set only, I have to use the element from this set only. So 1 minus 1 is 0, so that is divisible by 2. 1 3, 1 minus 3 is 2, so divisible by 2. If 1 3 means 3 1 also I can write. 1 minus 5 is minus 4, divisible by 2. I'll take positive only, so 5 1 also I can write. 2 2 is divisible by 2. 2 4 is divisible by 2. 4 2 means if I subtract is divisible by 2. So I wrote all the elements. Okay. Now to check reflexive, we have to see whether 1 1 2 2 3 3 4 4 5 5 is there or not. So 1 1 is there. 2 2 is also there. 3 3 is also there. 4 4 is also there. And 5 5. So each element is related to itself, belong to R. Therefore, R is reflexive. Clear? Next, go and let us check symmetric. For symmetric, what you have to see that if 1 3 belong, 3 1 also belong to R. See, we can see that 1 3 3 1 belong to R, and 1 5 5 1 also belong to R. Or you can write like that: 1 3 belong to R implies 3 1 also belong to R. 1 5 belong to R implies 5 1 also belong to R. 2 4 belongs to R implies 4 2 also belongs to R. 3 5 belongs to R implies 5 3 also belongs to R. So it is symmetric. Okay. Or you can say R is symmetric. R. Okay, this is R. Let's check transitive. Transitive, it's like that: if 1 3 belong to R and 3 something, 1 3 belong to R and 3 5, 1 3 belong to R and connected to 3 is 3 5, or 3 3 is also there. I can take 3 5. I have to use 3 number. Belong to R implies what? Does 1 5 belongs to R or not? So 1 5 belongs to R. That means it is transitive, but we can check with the other element also. 5 3 belongs to R and 3 1 belongs to R implies 5 1 also belong to R. So therefore R is transitive also. So R is reflexive, symmetric and transitive. At the end you can write, since R is reflexive, symmetric and transitive, R is equivalence relation. Okay. Let's do question number 13. Here, let Z be the set of all integers and R be the relation on Z defined as A and B are integers. A minus B is divisible by 5. So we have to check it's divisible by 5 or not. For reflexive, I can check with the same number. If A belong to integers, you have to check ARA. A minus A, we get 0, is divisible by 5. So R is now we'll check for symmetric. We use two numbers, so A, B belong to Z. If A related to B, what we get? A minus B is divisible by 5. We have to check for B related to A also. That means B minus A. If I take minus common, I can write A minus B, which is also divisible by, see, A minus B is divisible by 5. A minus B is divisible by 5. Doesn't matter if negative sign is here, it will be divisible by 5. So R is symmetric. Let's check for transitive. We use three terms A, B, C belong to Z. Then if A related to B is satisfied, that is A minus B is divisible by 5, and B related to C means B minus C is divisible by 5. We have to show that A related to C must be divisible by 5. I can write A minus C. Like in one of the question, A minus C is given. I can subtract and add the same terms, like I can add and subtract the B minus B plus B. Here this is also divisible by 5. This is also divisible by 5. So is this minus B plus B I add and subtract by myself, okay? You can use other alphabet also, but since I have to connect with this, I'm using this alphabet. It's divisible by 5. That means R is, since R is reflexive, symmetric and transitive, therefore it is equivalence relation. You can write down, okay? Let's do question number 14. Show that the relation R and AB belong to Z, that means integers, and A plus B is even, is an equivalence relation. This is also similar. For A belong to Z integers, we have to check ARA. Implies ARA means A plus A. If I'm using AB, A plus B, okay? So what I'll get? A plus A, that is 2A is even, because multiple of 2 is even. Now we'll check for symmetric. For symmetric, I need AB belong to Z. A related to B implies what? A plus B is even. So what about B related A? B plus A I'm getting. This also will be even. If A plus B is even, B plus A also will be even. That means R is symmetric. A plus B is satisfying B plus A also. Let's check transitive. We need 3 alphabet or 3 numbers. If A related to B is A plus B is even, and B related to C, B plus C is even, then we have to check A related to C. A plus C is even or not? If A plus B is even and B plus C is also even, that means A plus C is automatically even. Therefore, R is transitive. Since you can write, since R is reflexive, symmetric and transitive, therefore R is equivalence relation. Okay, you can pause the video to write everything. Thank you.